Hi members, my name is Mr. Ongaria. So today I want us to look at one of the techniques of integration called the integration by parts. So the definition of the technique is this is the integration by parts. This is the technique of integrating the product of two functions. Normally, the technique based on the product rule of differentiation. It's on the product rule of differentiation. Here, when you are given uh, the technique states that the integral of u dv dx and respective to dx should be equals to uh, u v minus the integral of v du dx respective to dx. So that's the formula of integrating functions. Uh, it is the formula of integrating the product of two functions. Take uh, for example, when you're given a function, when you're given a function, the integral of x e of x with respect to dx. Here, uh, one function has to be related to bu, then the other function has to be related to be dv dx. Here, the function related to bu should be easily differentiable such that we get the du dx. Then the function related to be dv dx should be easily integratable such that we get it, then we get v. Here, we're going to when you're integrating the product of two functions, we are going to follow the Liade rule. The Liade, the Liade rule. The Liade rule says that this is it. This one is the logarithmic function. This one is the inverse function. This one is the algebraic function. This one is the trigonometric function. This one, velocity, is the exponential function. How can we how can we identify the algebraic function, and how can we identify the inverse function, and how can we identify the logarithmic function, the trigonometric function, and the exponential function? This is it, the algebraic function. This one is our algebraic function. That's the one we're going to call it u because it's easily differentiable. Then the exponential function, uh, we call this one exponential. This one is the exponential function. The one we are going to let it be dv dx, such that it can be easily integrated. Here, when I'm using the diagram, the function that comes first before the other is the one that we're going to differentiate. Whereas the function that comes first before the other is the one that we're going to differentiate. Like following the Liade rule, the algebraic function comes first before the exponential function. Therefore, we're going to say uh, our u should be equals to x. When we differentiate to get the u dx, we're going to differentiate u with respect to dx. Du, we're going to get the dx. Therefore, our du dx should be equals to 1. Hmm? That is our du dx. To get the v now, we're going to say dv dx should be equals to e of x. Therefore, to get the v, we're going to solve first of all to solve this special equation. Then we integrate dv should be equals to e of x dx. Therefore, then we are going to integrate to get it, to get v. When you integrate dv, we are going to get v. When you integrate e of x with respect to dx, we are going to get it. That will very function e of x plus the constant of integration. But this constant of integration, you're not going to consider it when you're substituting the value of v and the ud dx into the formula. Is therefore from the formula you see integral of u dv dx with respect to dx should be equals to our u is the x, our v, we are putting v as it multiplied by the value of v, e of x, we are not going to consider this is equal this constant of integration minus the integral of v, which is the e of x times du dx is the 1 with respect to the x, which is equals to x e of x minus the integral of e of x with respect to dx. When you integrate e of x with respect to dx, we are going to get it that very function e of x minus e of x plus now the constant of integration. That is it. When we integrate, that's the answer. When you integrate, that is your answer. Thank you. See you next time.
Yeah. So it's this one I've captured last as I'm checking for the side, but I think it's okay.